Let's take a look at Leet code question 36, valid Sudoku. And this is a fun and pretty cool question to solve, in which we're trying to determine whether or not any row has a duplicated number or any column has a duplicated number. And we're also trying to detect whether or not any of these sub boxes have a duplicated number. So there's a little subtlety when trying to determine that. So let's jump into the question here. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. So each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. And then also each of the 9 sub boxes, the 3x3 sub boxes of the grid, must contain the digits 1 to 9 without repetition. And then there's some notes here. A Sudoku board partially filled could be valid, but it's not necessarily solvable. And only the filled cells needs to be validated according to the mentioned rules. So here we've got an example here. So we've got a Sudoku board here. And basically it's represented by an array of strings, because it needs to be a string, because if it's not filled in, we need to preserve the space with this dot here. So for example, the first row here has the numbers 5, 3, 2 blanks, and then a 7 here. And then that's how the rest of the rows are filled in. And if you take a look at this particular example, none of the rows have duplicated numbers, none of the columns have duplicated numbers, and also none of the sub boxes have duplicated numbers. Whereas if we were to look at the example 2 here, we would see, even though we don't get to see the board, if you look at the array of arrays, we can see that there's some duplication. So this is similar to example 1, except with the 5 in the top left corner being modified to an 8. And then if you see this next 8 here, that means there's another 8 in the column, so it's not a valid Sudoku because there's repetition there. So we get given the board, which is an array of string arrays. And I'm just going to rename that variable to rows, because rows is more descriptive, because that's what it is. It's an array of rows. And then that's going to help us not get confused between whether we're on a row or a column. So basically, we want to loop through each of the rows. So for row, let row of rows. Basically, what we want to do here is we want to detect whether or not there's any repetition. So let's go ahead and firstly filter out the dot if it exists there. So we can just take the row and then we can just filter out each of the numbers, and the number's actually a string there. So you might want to actually have the type there string. It is implied, but just because we got the variable name number here, I'm just going to make it explicit there. So if the number is not equal to the quote dot, which is what we get if there's no number there. So filtering, recall the filter higher order method in JavaScript, it returns everything that this evaluates true to. So if the number is not equal to dot, we're going to keep all of the numbers and we're going to filter out all of the dots. So then what we can do is we can just sort of use a set on the filtered row, and if the size of that is not equal to the filtered row length, that means there's duplication, because the set is a unique list of values, and if the sizes are no longer the same, then we have a duplicate number in there, and then we can just return false. So that's how we check through the rows and to see if any duplication occurs in any of the rows. So let's loop through and look for the columns if there's any duplication. So I'm going to track the index this time because we need to access a cell from the board. So we're going to let I equal to 0. And for I less than 9, which is the length of the board, I think it's okay to hard code the number 9 here rather than passing in the length of the board because this problem doesn't scale. So usually you would want to have a variable here, but since we have a Sudoku and the rules only really apply for a 3x3 subgrid or a 9x9 grid, I think it's actually preferable to hard code this value here to make sure that this isn't a scalable solution if the board gets bigger because the same rules wouldn't apply. So basically we want to work out what the columns are. So let me just copy this for loop here. And for J here, for I here, I'm going to replace this with J. And it's a square, so it's going to have the exact same numbers for the inner loop as well. And then what we can do is for each iteration, so for each row, we want to work out all of the column values. So outside of the nested loop, but inside the rows loop, we can create this column here. And this is just going to be an empty string array. And essentially what we want to do is for each row, so let's say we're on the first row, we want to get the column number and then push it to the cols array. So what we need to do here is we need to access the cell. So the cell referring to an individual box. So with this cell, we need to access the board and then we want to swap the rows and the columns because when we do so, we're going to get the row. So on the first iteration, we're on row 1. So that means in our nested loop here, we want to get each of the columns. So we swap the J and the I over. So another way to think about this is essentially we want every element, like let's consider we want the first row. Well, if we want the first row, the first column, let's say we want the first column, we want to get the element or the cell that is in the exact same spot. So let's say, and because this is a square, we can simply interchange these two values here. So for the first column, for the first row or the first iteration, we want to make sure that, well, we want to get the element from every single row. So all 9 of the rows, if we get the first element, that's the column. So we want that to be hard coded, or not hard coded, but we want that to refer to the outer loop. And then this one refers to the inner loop. So that's the spot in the Sudoku that we want there. So basically what we can do, firstly, we can just detect, well, if it is equal to the empty square, which is represented by this dot here, we don't really want to add that to our column because there's no need to, because we're only checking for duplicated numbers and we don't need to do anything related to unsolved numbers. So if we have a number in the column, or if the cell has a number, we push that to the column. So, and then at the bottom here, essentially we can do a similar thing to what we've done here. So we can say, well, at the end of this inner for loop, if the column, if that's not equal to the length of the col, then we can return false. So that's the exact same logic that we've done here, but we've applied that to the column. So what we've done here is we've detected if any duplication in the rows or any duplication in the columns. Now, so far this hasn't been too difficult, but we also need to determine the sub box as well. So basically, I want to have a catch case, or an end case here, let's say. Not a catch case. But basically, if it makes it past all of the checks, we can return true because then it is valid. So this is where I want to explain the sub boxes part here. So we need a way to add numbers to each sub box. So a sub box is 3 by 3 and there's 9 sub boxes. So the first sub box has the first 3 rows and the first 3 columns. The second sub box has the first 3 rows and then columns 4, 5, and 6. And then the third sub box has the rows 1, 2, 3 and the columns 7, 8, 9. And then the fourth sub box will have the values or the rows 4, 5, and 6, and then the columns 1, 2, and 3. So there's a bit of a mix and a match between the rows and the columns. And we can use that sort of 3 by 3 nature of this to our advantage. So this is like the subtlety to determining or getting the number into the sub box. So essentially what we can do is, because we're in this nested for loop, we have access to the particular I value and the j value, or the row and the column. And we can use that information to determine the index of the box that we're on. And then depending on the box's index, we can go ahead and push our array to that particular box. So what I want to do is I want to create a variable, and I just want to have the sub boxes. So I might do this outside of the for loop, so we only need to create this variable once. So just here, I'm going to create a sub boxes here. Now this is going to be a lookup, so an object which has the key, which is the box index, which is going to be a number. And then we want all of the numbers, and our numbers are string arrays or strings. So multiple will be a string array. And we're going to initially just set this to an empty lookup here. So the idea here is, well, we don't have an array here because it's a lot harder to just simply push to an array just by the nature of how we've got this question. We need to do some sort of lookup based on the particular index we're on, and then if something exists, we can add. Well, if something doesn't exist for the lookup, we can add the cell to the lookup. But if it does, we will have a invalid Sudoku there. So what we can do inside this for loop here, after we push the cell, we can work out what the index of our box is. So this is probably the trickiest part of the whole question, because if we can determine the index of the box, we can simply just push it into our lookup. And if we find a duplicated value for that particular box index that we're looking at, then we know this the Sudoku is not valid. So this is the trick here. Basically, we want to use the particular row we're on and the particular column that we're on to work out what box we're in. So we know that the first three rows, they correspond to either box 1, 2, or 3. And as I've been talking with the numbers 1, 2, 3, but in computers, we're going to, or in arrays, I should say, we're going to have a 0 index there. So basically we want the index to be 0, 1, or 2 if it refers to the first box, second box, or third box respectively. So how can we do that? Well, the first thing to note is we're going to need to work out what row we're on. So to work out what row we're on, how that corresponds to what box we're in. And we can actually use the math number here, because you'll notice that the first 3 rows will result in either the first, second, or third box. So what we can do is we can use the floor method, and we can take the row we're on and we can divide that through by 3. So that means if I is equal to 0, this whole thing will be 0. So, and we're just considering the first box for now. We'll add on the next box there. But let's just consider the first box. If we're on the row 0, and you know the column's going to be the first, second, or third, or 0th, first, and second index. If we're on the 0th row, this is going to result in 0, so the box index will be 0. If this is 1 or this is 2, this is also going to go down to 0. So if we're on rows 1, 2, 3 for the first 3 columns, this will go to 0th index. So what happens when we go to the 4th row? Well, 4 divided by 3, if we take the floor of that, that's simply going to be 1. So that means we would be on the first index, but that's not right, because we know that the 4th row corresponds to the 4th box. But because we're dealing with indexes here, it's 1 less than that, so we're dealing with the 3rd one. So what we can do, the trick here really is to multiply things by 3. So let's just take a look at that. So we're just considering columns 1, 2, and 3 at the moment. So let's consider the 4th box, which is the, and then also the 7th box. So for the 4th box, we know that rows 4, 5, and 6, or 3, 4, and 5 in the indexes, if this is 3, 4, or 5, then this whole thing is going to be 1, and then 3 times the 1 is 3, and 3 corresponds to the 4th box because it's 0 index. And then let's do the same thing for the 7th box. Well, we're considering the numbers 6, 7, and 8. So 6, 7, and 8 divided by 3, and you take the floor of that, that's going to be 2, and then 2 times 3 is 6, and then that's the 6th index. So starting from 0, that's the 7th box. But how do we get the other columns? How do we take into account, well, what if we're not on the first 3 columns? And this is where we can just go ahead and we can just add on that. So we can just plus on the floor of j divided by 3. So let's think about the 3rd box and the 9th box, or the 2nd index box and the 8th index box. So let's say we're on the first row. we've already done the calculations for this part here. So if we're in the first 3 rows, this is going to simplify to 0. So if we're in the third box or the second index, we know that j is going to be equal to 6, 7, or 8. So 6, 7, or 8 divided by 3, and then taking the floor of that, that's going to be equal to 2. So the 0 plus the 2 means you're in the 0th, 1st, 2nd index spot, or the 3rd spot there. So let's just do that one more time, just to bring the point home for the 9th box, or the 8th index sub box. And essentially, what we can do there is, well, let's say we're on the last row. So I equals to 8. Take the floor of that. That's going to be equal to 2. Times it by 3. That's going to be the 6th index. And then if j is also 8, this is going to simplify to 2. So then we've got the 6 plus the 2, which is 8, which is the 8th index, which is 9. So this is pretty much the trickiest part about the whole problem here, is realizing that you can use this sort of approach to be able to work out what the sub box index is. And once you've got that, you can actually find it quite easily. Because you can see we can use this sort of lookup thing we got here. So this is sort of similar in a sense to the two-sum question, where, well, in a way where we're tracking numbers, but then also similar to this, where we're, after we've tracked the numbers, we can look for any duplication in that. So basically, since we've got the box index now, things become a lot simpler, because what we can say is we can have an if else, and basically if the sub boxes, so right now the sub boxes is just an empty map there. If the sub box, so if we try and look something up for the box index, so the box index is the key there for the number. So if we try and look something up and then nothing exists there, well, we can simply just take that sub box and then add that key there. And then the value we're going to assign to that is we're going to give it the cell that we're on. Because whatever particular number we're on, we loop through the row and the column. Whatever cell we're on, that's what we're going to add. And we're going to add it inside of this array, because we're going to need to push other cells to this sub box index here. So that's why we've got this string of array types here. And then else, what we can do is we can just take our sub box here. So it means that we already have a key with this index, perhaps on a different iteration. So for that, we can simply just push this cell, because the array already exists now as we've created it here. And one last thing we'd want to do is we want to determine if there's any duplication within the box. So when we did it for the set, we've done it after we've sort of filtered the row, or, you know, we've got all of the column numbers in the columns array. But since we've got a map data type here, we can just go ahead and we can just say, well, if the sub boxes, if we have a box index here, because we know, well, we know it's going to have a box index because we're in this else part here. But if the values, or the string array, if our number, which is a string here, if that number is equal to the cell that we're on, we can just simply return false, because it already exists. And this is just a lookup here. So that's O of 1. And if it already exists, then, well, it's already in the lookup, that number. So we say it's not a valid Sudoku. And if it makes it past all of these checks, we can return true. So let's go ahead and submit that. And we see that this beat 74%, so that's not too bad. Thanks so much for watching, and I'll see you in the next video. Cheers.